Hello, my dear student. Welcome to another edition of your mathematics lesson today in continuation with your main topic, that is longitude and latitude. What we are going to learn today is how to find the distance between the 2 points that happens to be on a parallel of latitude. So let's begin. After completing the very lesson today, my dear student, will be able to calculate the distance between the 2 points that happens to be on a parallel of latitude. This is what I hope you'll be able to do after completing the very lesson today. So my dear student, as usually the favorite segment of the lesson, that is Maths Fun. Today, I'm happy to give you relationship between sequence of odd numbers and the cube numbers. So I'm going to show you today how you can now form a cube number from the sequence of odd numbers after completing my lesson today. My dear student, to begin the lesson, let us just consider 2 points P, which is on the location gamma degree north and alpha degree east, and another point Q, which is on the location gamma degree north and beta degree west. You can see these 2 points P and Q have common latitude. Look at the common latitude gamma degree north. So which means the 2 points P and Q, as you can see in this drawing, happens to be on same latitude, and that latitude is gamma degree north. So this distance between P and Q along the parallel of latitude, meaning the distance between P and Q that happens to be on the same latitude, and that distance PQ is nothing but the length of this arc PQ. Look at the arc PQ. So the length of this PQ, which we now say is the length of this very arc, will now be nothing but the formula theta over 360 multiplied by 2 pi small letter r, where the small letter r will now be the radius of that very latitude. So small letter r, which denote radius of the latitude, is the same thing as capital R, that is the radius of the earth, course gamma, where this gamma is always the angle of that very latitude. So in this case, it is latitude of P and the Q, and the angle of that latitude is gamma degree. So this radius of this very latitude can be resolved in terms of radius of the earth by using this very formula. Radius of any latitude equals to radius of the earth multiplied by cos gamma, where gamma is the angle of that very latitude. So if I now rewrite this very formula, removing this small letter r and writing capital R cos gamma, I'm going to have my new formula as theta over 360 multiplied by 2 pi r cos gamma. So this is what we shall be using to find the distance between any 2 points that happens to be on same latitude. So where the theta is now difference in their longitude, and r, like I've said, is 8 radius. Pi is usually given in the question either 22 over 7 or 3.142, and the gamma is the angle of that common latitude. So this is what we shall be using to find the distance between the 2 points along parallel of latitude. Let's just take examples. Example number 1 is, says if P is a point on this location, that is on latitude 60 north and longitude 20 east. Another point Q, which is on latitude 60 degree north and longitude 50 degree west. These 2 points P and Q are points on the earth's surface. The question asked is to calculate the distance between P and Q along the parallel of latitude. You have to take up R as 6,400 and pi as 22 over 7. Solution to this very problem, what we do first is to have a sketch of these 2 points on the earth surface. So let me draw my earth. Let's see it. This is my earth. Then I will now look at the question. The point P is on latitude 60 north. The point Q also is on latitude 60 north. P 60 north. 60 north is the common latitude. So I'll now draw that latitude first. Then I'll move to the point P. Is on longitude 20 east, longitude 20 east. So I will now draw my longitude 20 degree east. Look at it. This is my 20 east longitude, and where the 2 crosses will now be the position of the point P. Then moving to the point Q. Q is on longitude 50 west. Longitude 50 west. So let me draw it so that I'll have the position of Q exactly. So this is 50 west. So where the two crosses, that is the longitude 50 west and the latitude 60 north, where the two crosses will now be the position of Q. So the distance PQ would now be nothing but the length of this very arc. You can see the arc PQ subtending an angle theta, and the radius of that very latitude, which is a circle, is denoted by small letter r. So distance PQ would now be equals to this very formula, theta over 360 multiplied by 2 pi r. This is the formula for finding line of arc, where r is the radius of that very latitude 60 north. But remember, we have way of resolving small letter r, radius of any latitude, in terms of radius of the earth, which we said this r, small letter r, is capital R cos gamma, where gamma is the angle of that latitude. And in this case, gamma is now 60 angle of that common latitude. So I can now rewrite this very formula, r theta over 360 multiplied by 2 pi capital R cos 60. 60, I repeat, is the common latitude, 60 degree north, instead cos gamma. Gamma is the angle of that common latitude. So substituting now, I'll have my theta. You can see theta, which we said is the difference in their longitude, 20 east and 50 west in different directions. So we add 20 and 50 to get this theta. So let me do that somewhere here. So my theta will now be 20, that is this longitude, plus the 50, which is this longitude, because they are in different directions, east and west. So I add. So that gives me 70. So I can come back to this very formula, substitute theta, r, and the pi, which I have in the question. So substituting it there, you have 70 over 360 multiplied by 2, multiplied by 22 over 7, multiplied by 6,400, multiplied by cos 60. So what I'm going to do next is to get what is cos 60 from my calculator or from my four-figure table, the value of cos 60. So let me find it and substitute. If you check it correctly, cos 60 with your calculator is going to give you 0.5. I copied all other values. So there, multiplying this correctly and dividing, if you do that correctly, you're going to have 3,911.11 kilometers as the distance between P and the Q along this common latitude 60 north. So let me take one more example. Example number 2, it says an aircraft fly from Tower X, and that Tower X is on the location 50 south and 15 east, and that aircraft fly from X to another town Y, and this is the location of the town Y, which is on 50 south and east 80 east. If it takes 5 hours, maybe from X to reach Y, it takes 5 hours. The time to the question asked here is to calculate the speed of the aircraft. You have to take a radius of the Earth as 6,400 kilometers and the pi as 3.142. Solution to this very problem, what we do always is to have a sketch of the two towns on the Earth's surface. That is what we do all the time. It's very, very necessary. So let me have a sketch of my Earth. Starting with the point X. The point X and Y, if you check carefully, you can see that they have a common latitude 50 degrees south, 50 degrees south. Look at it, 50 degrees south, 50 degrees south. So the 2 points X and Y, or rather the two towns X and Y, happens to be on same latitude. So let me draw that common latitude, 50 degrees south. Let me have it. Look at the 50 degrees south. Now check this or sketch this, find the location of X. I'll now draw this longitude 15 east. 15 east will now be somewhere here, longitude 15 east. So where the two crosses will now be the position of the town X. Then I'll move to the position of the town Y. Town Y is 80 degree east. 80 degree east will now be somewhere here, longitude. It is somewhere here because If the middle is the prime meridian, remember, as you move away from the prime meridian, the angle of that longitude keep increasing. And as this is 80, while the other one is 15, so 15 will now be closer to the prime meridian, while 80 will now be far away from the prime meridian. So my 80-degree east will now be somewhere here. Let me draw that. So this is my longitude 80-degree east, and this will now be the position of the town Y. So that aircraft started from X and moved to town Y, and it takes 5 hours to reach town Y. So I continue. So what I will now do is to find the distance XY, that is the distance between the two towns. Then later on, I will now use the distance to find the speed, because the question asks us to find the speed of the aircraft. So let me attempt to get the distance between the two towns X and Y. That distance would now be nothing but the length of this very arc. Look at the arc in blue. That arc obtained the angle theta at the center of that very latitude 50 degrees south, and the radius of the latitude is denoted by small letter r. So the distance xy will now be nothing but the formula for length of arc, which is theta over 360 multiplied by, instead small r, I now have a capital R cos 50, where 50 is the angle of that common latitude, 50 degrees south. Remember, this R cos angle of the latitude is the same as the radius of any latitude. So I continue. So I'll now substitute my theta, my R, and the pi. But to get a theta, looking at these two, point X and point Y happens to have longitude 15 east and 80 east. The two longitudes are on same direction. And it is difference in those longitude that gives you this very theta. And if the two are on the same direction, we now subtract the smaller longitude from the higher longitude. That will give our theta. So let me do that. So my theta will now be 80 minus 15. That gives result 65. So I can now go back to this very formula. I have my theta, I have my pi, my r. So substituting there, you have 65 over 360 multiplied by 2, multiplied by 3.142, that is your pi, multiply by 6,400, that is your capital R, then multiplied by cos 50. If you check your calculator, you have 0.6428. And simplifying this correctly would now give a result 4,668 kilometers as the distance between the two towns X and Y. So we can now answer this very question, that is calculating the speed of the aircraft. The speed, remember, in your physics is nothing but the distance divided by time. I have the distance between the two towns as 4,668. And I have the time taken by the aircraft from X to reach town Y. So I can now divide this distance by the time to get the speed. So I have 4,668 divided by the time. If you do this division correctly, you have the speed of the aircraft as 933.6 kilometer per hour. This will now be the speed of the aircraft. So my dear students, with the few examples given, I hope you'll be able to find the distance between the 2 points that happens to be on a parallel of latitude. Thank you for your attention, and let me just move to the last segment. Maths is fun, and they explain how we can now create, or how we can now form the cube numbers from the sequence of odd numbers. So it says if we are to find, that is, if we are to group odd numbers into groups of n numbers, where n can be 1, 2, 3, 4, and so on. That is, if we can now just form a group of numbers, and those group of numbers may be started with group of 1 number, group of 2 numbers, group of 3 numbers, group of 4 numbers, from your sequence of odd numbers. And those group of numbers, if you are now going to add those numbers in each group, what you are going to have is a cube number. Let's just try it and see. If this is your sequence of odd numbers starting with 1, 3 is the next odd number, 5 is the next odd number, 7 is the next odd number, 9 is the next, 11, and so on. So this is your sequence of odd numbers. And I try to group them into group of 1, group of 2, group of 3 odd numbers, group of 4 odd numbers, group of 5 odd numbers, and so on, because it says I should group those numbers into one group of 1, group of 2, group of 3, and so on. So these are the groups. This is the very first group containing only one odd number. Next group containing 2 odd numbers. Next group containing 3 odd numbers. Next group containing 4 odd numbers, and so on. So what this property is saying, if I add all the numbers in each group, what I'm going to have is a cube number. Let me just say, the very first group contains only one number. Addition of that one number gives you 1, and the 1 can be written 1. Look at it. This is 1. Next group is 2 numbers. If I add 3 and 2, it will give me 8. Next group contains 3 numbers, and those 3 numbers, if I add them together, if you did correctly, it gives you this result, 27. Next group, there are 4 numbers there. Addition of those 4 numbers correctly gives you 64. Next group, 5 numbers. Addition of those numbers done correctly is 125. Next group, addition gives you 216. So what this is saying, this is sum. This results after adding. Each of them will now be a cube number. Of course, 1 can be written 1 raised to 3. So what is a cube number? 8 can be written as 2 raised to 3. So therefore, 8 is a cube number because it can be written in index form with the power 3. That is something raised to the power of 3. So 8 is a cube number. Let me check 27. 27 is another cube number because it can be written 3 raised to the power of 3. I'll continue. 64 is another cube number because it can be written 4 raised to 3. And next is 125. This is nothing but 5 raised to 3, so it is indeed another cube number. And 216 is another cube number because it can be written 6 raised to 3. You can now find those values and see whether it gives you this exactly. And you can see those 1, 2, 3, 4, 5, 6. So the next group will now be having 7 raised to the power of 3. This is really interesting. I believe you have been writing sequence of ordered numbers, but I doubt if you noticed that there's a relationship between ordered numbers and the cube numbers. Thank you for your attention. We'll see more of this in our subsequent lessons.